It's time to go ahead and get the homework done. I'm going to go ahead and work on all the even ones today. And we're starting with number 10. Jan saw, it says write each statement as a rate. Jan saw 9 full moons in, let's see, 252 days. So 9 full moons in, that's going to be 9 moons in 252 days. That would be our rate, okay? And since we did have a dust at full moons, I guess I should be even more specific. We're going to put it as full moons instead. All right, so 9 full moons in 252 days. All right, number 12 is next. It says find the value of x. So we got to figure out what this is. We need to see what the ratio increase here was. So I could take 48 and divide it by 16. I see that it goes into it 3 times because I know 3 times 6 is 18. And I carry the 1. That's going to be 3 times 1 is 3 plus 1 will make 4. So that's 48. So that means it increased it 3 times, which means I've got to increase this by 3 times. And 2 times 3 is 6. So x equals 6. All right. Number 14 is next, for me anyways. In 14 to 15, find the unit rate. So we're trying to find out what 1 is here. We see we got 320 miles in 16 gallons. They're dividing both by 16, because that's what you do, 320 divided by 16. And that gives you what? Well, we're going to take 320 and divide it by 16. I know 16 goes into 32 twice. And that leaves us with a 0, so I'm going to have to fill that with a 0. So I'm going to go 20 times. So that means I get 20 miles for every 1 gallon. All right, going to number 16, complete each table. I got to see how much it increased from here to here to here. Let's see here. It was 18, got 1, then we got 10, and we got 15. So we have to ask ourselves, in 1 minute, okay, over here it increased by 5 each time, right? Which means it had to increase by 5 each time over here. We have to see where that started with, though. Over here, so we got 18 and 9. We're going to have to see, well, that's half as much, right? So I'm going to feel like the top part might be half, but that's not a guarantee, is it? Because we have to figure out what the rate is that changed. Let's not forget, we always put y over x, and if this is x and this is y, that's usually how our tables go. This would be 18 over 9, and 18 divided by 9 equals 2. So we're multiplying whatever is up top by 2, right, to get to this. So what would I multiply it? Well, you could also say you're dividing whatever's on the bottom by 2, right? So 1 divided by 2 is going to be 0.5. That's a half. 10 divided by 2 would be 5. And 15 divided by 2 would be 7.5. All right, going to number 18 now. Again, we can find the rate here. This is 2 over 2, see, 24.6. And we do this, we realize they can both be reduced by 2, right? We can divide both of these by 2. So we'll divide it by 1 in the form of 2 over 2. And that means 1 ounce is going to be equal to 12.3. bags. So this would be 12.3. Because it means we're multiplying everything on the bottom to 12.3, right? So 5 times 12.3 will be what? Okay. 12.3 times 5. Oh, sorry. Totally messed that up, didn't I? Times 5. 12.3 times 5. And we got 3 times 5. That's going to give us 15. Carry the 1. Got 2 times 5. That's 10 plus 1 makes 11. Carry the 1. And 5 times 1 is 5 plus 1 equals 6. And that decimal has to come down. Since we went over 1, we have to bring it over 1. That's going to give us 61.5. Next, we got 123. This is not going to be hard because I know if I had 12.3, the decimal moves over 1. So I would say that 10 times 12.3 will give me 123. All right, let's move on to number 20. It says, which runner sets the fastest pace? We got Martha, Allison, and Rachel. And we got 20 laps in 32 minutes. So that would be 32 minutes divided by 20 laps. We'd be able to find out how much she does in 1 lap, right? For Allison, it would be 25 in 16 minutes. That's 25 divided by 16. The last one is Rachel, and that's 27.2 minutes and 17 laps. All right, so let's go ahead and use the calculator for these so I can do a little quicker. First one is 32 divided by 2. This is going to be, or 20 to be, it's easy to see it's going to be probably 1.6, but we'll go ahead and check it out. 32 divided by 20, and that does, let's try that again. 32 divided by 20. For some reason, got 32 divided by 33 there. Let's try it one last time. 32 divided by 20. That gives us 1.6, just like I thought. So her rate is, she does 1.6 laps in, actually she does 1.6 minutes per lap. All right, let's try Allison's. And Allison does 25 minutes in 16 laps. So that's 1.5625. 1.5625. All right, and then we have Rachel last. And Rachel does hers in 27.2 divided by 17. That is 1.6 as well. I'm going to double check that one more time. 27.2 divided by 17. So they said, which one sets the fastest pace? Well, the fastest pace is going to be who does one lap the fastest, and that's got to be Allison. She's doing it in 1.56. We're going to go with Allison. Okay. And I guess the reason, let's see here, does say explain, so we have to show our reasoning for this. Allison, let's see, because she only takes 1.5625 minutes to run each lap, while Martha and Rachel take 1.6. And that's it. Let's go on to 20. I think I got 22 since I'm the even ones here. As an elephant charges an object that is 0.35 kilometers away, how long will it take the elephant to reach the object? Well, remember, elephant can charge up to 0.7 kilometers per minute. So how long will it take the elephant to reach that object? So that tells me that this is going to be, remember that formula I had, distance equals rate times time. We're trying to find out how long it will take. We're looking for the time. So we're going to rearrange this and divide it by the rate, which means we'll divide the distance by the rate. So our formula for this will be the distance divided by the rate will equal the time. The distance is 0.35. And the speed is 0.7 kilometers per minute. So that's 0.7. Now I know I have to move my decimal over 1, which means I have to move this one over 1. And I know 7 goes into 35 5 times, so this would be 0.5. So I can say that the elephant will reach the object in 0.5 minutes. Okay, so we're talking about 30 seconds basically. Better get out of the way quick. And the last one for me, how are the thinking question? How are the ratios 24 laps in 1 hour and 192 laps in 8 hours alike? How are they different? Well, if I was to take 24 and multiply it to 8, let's see what happens. Well, 24 times 8 equals 192. So that tells me how are the ratios alike and how are they different? Well, they're alike because they're both the same rate, right? They have equivalent values. So if I just say this one, I would say that both are both of these rates, both of these ratios are rates, but 24 laps over 100. Let's see, 24 laps over 1 hour, excuse me, is a unit rate. And 192 laps over 8 hours is not. All right, that's like all the ones that I had to do. So calling it a night. Good luck with the rest of yours, and I'll see you for grading later.